can use other softwares like Multisim or MATLAB, but this one is more simpler compared with them. So the outlines of this presentation are what is Psim or PowerSim, how to install Psim interface presentation, simulation using Psim, then getting started with Psim, then we do some examples. Okay, so what is Psim? Psim is a simulation software specifically designed for power electronics, motor drive, and power conversion system with fast simulation, speed, and friendly user interface. Psim provides a powerful simulation environment to meet your simulation and development needs. So the manufacturer is PowerSim Incorporation. This is the interface of Psim you are seeing here, and this is Psim software. Of course, we are going to work in parallel, presentation and simulation. So Psim include the basic package as well as the following. So what we can do with Psim. So the main application, we have the motor drive, the digital control, SIM coupler, which means that we can connect Psim to other softwares. Okay, renewable energy, SIM coder. So with Psim we can open a window that we can program with C language in the Psim software, and also the hardware implementation. So Psim is compatible with some hardware like Texas Instrument, DSP boards. Okay, so we can do some hardware implementation using Psim. So motor drive module is to provide built-in electric machines and mechanical loads. So this for electric machines application. Digital control module is to provide discrete elements such as transfer functions, as you have studied in linear system. Z transform, block in frequency domain, in the Z domain, digital filters, digital control, etc. SIM coupler module is to provide interface between Psim and MATLAB simulating. So this application is for the coupling between Psim and MATLAB simulating. So we can simulate some systems in Psim, then we can use them in MATLAB simulating. Renewable energy, such as solar systems or wind applications, we can find some blocks in Psim. SIM coder is to provide an automatic code generation, and at the end the hardware implementation using this Texas Instrument board. It's to provide function block for automatic code generation for Texas Instrument F28335 DSP. Also, in Psim consists with some applications. We have the main Psim software here when we can connect our circuits. Also, there is another applications that included in Psim, like this one, which called SimView. SimView is used for waveform processing. Okay, so we can deal with waveforms that we extract from Psim. In addition, this application, which called Smart Control, is specifically for the design of power converters. You can see here, this is another application. We may use it someday, use it specifically for the design of power converters. Like here you can see single loop DC converter, DC converter, PFC converters. Okay, so how we can conclude the work with Psim. So inside Psim, we can see we can have power electronics, renewable energy, thermal modules, SIM coder, motor drive. This is the simulation inside Psim. Outside Psim, we can do some hardware implementation using DSP hardware or FPGA. Also, we can do design using SIM coupler, which is application accompanied with Psim, and we can do also SIM coupler with MATLAB simulating. So with Smart Control, Psim, SIM coder, PowerSim provide a complete platform for design, simulation, and hardware implementation. You can see this application is not that huge in size, but it can do many interesting applications. Okay, so how we install? I have provided, so this is the software hardware requirement. You can see that it does not require a huge RAM. So 128 megabytes is satisfied for Psim. Okay, that's why I prefer it compared with MATLAB, which require a huge RAM. You can find this cracked version 9.1 to 2011 in the following links. Also, I add a portable version that you can use directly, like the one I'm using now. Okay, I will show you. You can find it in the second link. When you download it, you can run this version directly. Just you need to open this patch. Okay, 5 steps. You can patch your software, and you can use it directly without installation. Okay. Also, those are the steps of installing Psim, the first version. Okay. Of course, we have to accept these license agreements. Then the second step, we have to choose this soft key, this third choice. So the software here is asking for the license file. So we give it this license file. Then, of course, next. After the installation, so we have to take those 2 files, the patch files and the registry file, to this path. Okay, this is the path where the software is installed. Then we do the patch. Then we can run Psim. Okay, now let's describe the Psim interface. So this is the Psim interface. We can see here the menu bar, the toolbar, the circuit window, how we can do our connections, and the element bar. Okay, so let's go to Psim. So this is the Psim interface. We can here have a menu bar. Of course, you can see the role of each menu. We have the toolbars and the space when we connect our circuit, and the element bar. So we can take those elements, okay, and put them in this space. Not all those elements. We have here the element menu. We can find more and more elements, not just those presented here. Here, just the most used elements, you can find them here. So the simulation using Psim. The Psim simulation environment consists of circuit schematic program, okay, which is a Psim. So firstly, we connect the circuit in Psim, then we run Psim simulator. Then the third step is to see the result in the SimView. So we run we design our circuit in Psim firstly, then we run simulation with Psim simulator. Step number 3 is to see our signals or our outputs or our waveforms in the SimView. So the first step is how to create a circuit in Psim. So how we can create circuit in Psim? We have different kind of blocks available in Psim. We're gonna see them later. After this presentation, we are gonna run an example. We have, for example, power circuits, control circuits, sensors, and switch controllers. Okay. So in each circuit, we need those kind of elements. So we have a power circuit, for example, like the power electronics devices, they consist in power circuits. Sensors like the measurement devices, voltmeter, ammeter, etc. The switch controllers, those are switch blocks that use it for power circuit. For example, when we have a controlled converters like controlled rectifier with thyristors, for example, you may see it later. Of course, we need switch controllers to control those switch. I will do, inshallah, another presentation later, how we can do a controlled rectifier in Psim, and at the end, of course, control circuits. So the power circuit consists of switching devices, RLC branch, transformers, and coupled inductor, etc. So all of these are included in power circuit like those. We can see resistor, inductor, capacitor, RLC branches. We have switches like diode, thyristors, triac, and GTO, MOSFET, etc. So all power electronics devices that we need, we found them in PowerSim. Also, transformers, you can see here, we can find transformers, 2 winding, 3 winding, until 6 winding transformers. Other components like electric machines, for example, this is an induction machine, AC machine, or armature winding of DC machine. This is a solar panel. Okay, all these elements are included in the power circuit. We have also voltage source, current source. All of these components are included in power circuit. The control circuit, of course, represent in the block diagram. What are the control? Like the transfer functions, for example, or the logic gates. Okay. The transfer function in S domain of Laplace or in Z domain, for example, and the logic gates. All of these are included in the control circuit. Sensors are used to measure power quantities like voltage, current, power, etc. For example, this is a voltage sensor, this is a current sensor, this is a voltage probe or voltmeter. Okay, so gates and signal are then generated from the control circuit and sent back to the power circuit. So if we want to do the control, of course, the control signals generated from the control circuits to the power circuit. So how we can use Psim? How we can create a circuit. Okay, for example, here below we have the element bar. For example, here we can take, for example, an AC source. We can take, for example, a resistor. Okay, we can find other elements like a capacitor, like a diode. So as I said, this is not all the elements. Okay, we may find more and more elements in these menu elements. Okay, so firstly we can get different elements from the elements bar. So then the second step, how we can rotate them. Okay, for example, we can select this element. If we want to change its direction, you can see here this button. Okay, maybe here is clear. Okay, you can see here this button, this here. Okay, we may see here this button is to rotate elements. Okay, for example, let's go to Psim. For example, we have this diode. For example, I want to rotate it. Okay, I use this button. Okay, to rotate it or to rotate it. Okay, I can use this button to rotate it. Okay, to flip it in to the direction I need. So I can use this button. Also, there is another way. For example, when I select element here from the element bar, so I have a diode here, I can press my mouse button to connect, to put it in this space. If you want to rotate it, I can click the right button of the mouse. Okay, you can see here it's rotating using the right button of the mouse. So this is how we can get some elements from the element bar. You can use either this to rotate them, or we can use the right button of the mouse to rotate those elements. Now, how we can connect the elements to each other? Okay, so this is the first how we can rotate them. The second step, how we can connect them. There is the wire. There is a pen used for a wire. So to connect wire between two nodes, so the image of the pen will appear on the screen. So here you can find the pen that's used to wire. For example, we take this pen, you can here see it's wire, and we can connect those elements like this, those nodes. Okay, we can connect those nodes to each other. So this pen is used for wiring elements. Okay, is it clear how we rotate and how we wire elements to each other? I hope it's clear. Yes. Okay, great. Okay, so this is the steps, the main steps how we can connect the circuit. We repeat it. We can take some elements from the element bar. For example, we need a source. Okay, so we can rotate it by the right button of the mouse, or we can use this button here to rotate. Then we can connect them to each other using this pen for the wiring. Okay, so this pen used for the wiring. Okay, so here how we can create, this is the first step, how we can create the circuit. Now let's see how we can configure this circuit. There is another element which is important in the simulation, which called simulation control, which is this clock. Okay, so after connecting the circuit, we need this clock. Okay, so it's very important. Okay, the simulation control element define parameters and setting relate to simulation. To place simulation control element, go to simulate menu in Psim and select simulation control. So you can see this clock here. So it's used to configure our simulation. So let's go to simulate menu. We push simulation control and we bring this clock, okay, and put it in the circuit. Okay, so using this clock, we can configure, for example, our simulation. And one important thing in our simulation is the time. Okay, of course, when we work in the lab, we work in the open time. Okay, so the circuit is running, okay, until we stop it. By in simulation, we can select the time to simulate, how much I want to simulate. For example, here you can see time, total time is 0.01 second. For example, I can change this time. I want to simulate, for example, for 100 millisecond, which is 0.1 second. If we want to make it open, we can select here is free run. So the time is open now. We can, it will keep, so the software will keep simulating until you stop the simulation. But if we want to, for example, to see such number of periods, okay, so a defined number of periods. For example, I need 5 periods or 10 periods. I want to see 5 periods or 10 periods. We can select a time. For example, here we can select a time, for example, 0.1. So this is the importance of the simulation control element. Now, if we want to configure our element, for example, resistance or source, double click here. For example, this is a voltage source. When double click in each element, it will give us its configuration. For example, a double click on this voltage source, we can see here the voltage amplitude. For example, we can change it. Let's put 25 volt. The frequency, let's change it to, for example, 50 hertz. The phase angle, okay, the phase angle, the DC offset, the time T start, the time when this source starting. Okay, so this all the configuration of this block. Of course, we can change also its name, and we can change its color. Okay, here we can change its color. Okay, for example. So here how we can configure any element. Also resistance, double click here. For example, we can select its value. For example, 12 ohm, let's make it, for example, 500 ohm. Okay, so this is the value of the resistance. Okay, so the diode here, we consider it as an ideal diode. We don't have any we can select, for example, the threshold voltage. You know, the threshold voltage of the diode is 0.3 or 0.7, but here we are using an ideal diode, so we don't have any parameters. Also, there is, of course, it has an internal resistance, etc. So if you want to configure it any element, you just double click on element, and we can configure it as we want. So let's repeat the step that we have done. Firstly, we bring elements from the elements bar. We can rotate them, or then we wire them. After that, we bring the simulation control from simulate menu to configure the type of simulation. For example, here we choose 0.1 second. Then we can configure our elements. Our elements, like this voltage source, we can select its peak value, the maximum value, amplitude, and we can select its frequency and phase angle. Also, the passive element like resistance, double click, we can select its value. I hope this step is clear. Now, let's see. We said at the beginning. Let's go back a bit. So we said that the first step is to create the circuit, Psim schematic. Then we run the simulation using Psim simulator. Then we observe our signals using a SimView. Okay. So what is a SimView? A SimView is a software included. It's separated, but it's included in PowerSim. Is used as oscilloscope. Okay. So which can observe a different signal. So this is the screen of SimView. SimView is a Psim waveform display and post-processing program. So it's used after the simulation. Okay. So here we can see the interface of SimView. So let's start working with Psim, and I will show you how we can use how we can use SimView. Okay. Hajar, we don't need any serial number. If you follow the installing, how I install it, you don't need any serial number. Okay. So let's do an example.